So here I'm going to show you an example. It's the example in our problem 2 of our worksheet. If this one is problem 1, all you need is a symbolic equation for the uncertainty propagation. So you would write delta Q over Q, apply rule number 2, but here you have 4 variables. Delta 3 over 3, delta A over A, delta B over B, delta C over C. The sum of the relative uncertainty is the relative uncertainty of the result. Delta 3 is 0, so that term is gone, and you have delta A over A, delta B over B, delta C over C. If this one is question 1, then this would be the answer. But because question 2, we are given some numbers, so we should finish the calculations, numeric, put the numbers in. So here I have, first your calculations, you only need the values. So A is 3.3 meters squared, B is 2.2 meters, and C is 5.5 meters. And you calculate that to be 3.96 meters squared. To calculate the uncertainty, we plug in the numbers in our uncertainty calculation. 0.5 over 3.3. For the relative uncertainty, you can forget about the units because the units should be the same for the uncertainty and the value, so they do cancel out. You calculate this out and you got 0.2333. Okay, keep many digits here. Now to get the absolute uncertainty, you take you know it's the relative uncertainty. This is the relative uncertainty times the value. So that would be 0.2333 times 3.96 meters squared. That equals to 0.924 meters squared. Now it's time to round off. So this equals to, you round it to one non-zero digit. And you look, this has only one decimal place, which means your result should only have one decimal place as well. So in your answers, you would say Q equals to, round to one decimal place. This will equal to 4.0 plus minus 0.9 meters squared. If you like, you can put the percentage uncertainty in. That's plus minus 23%. So this is the answer for this example. Now I'm going to do problem 3 in our worksheet. First, you do the calculation with the given formula, and now you have to consider the uncertainty. This one is a little bit complicated because that formula has both multiplication and subtraction in it. Do you want to start with delta Q or do you want to start with delta Q over Q? Because the final calculation is a subtraction, so we are going to start with absolute uncertainty. Delta Q, apply rule number 1. So it equals to delta 4HW, absolute uncertainty, plus delta A. Delta A is already known, so that's okay. How are we going to find delta 4HW? So go back to your uncertainty propagation rules and you look at your rule number 2. Because we want to find the absolute uncertainty of a product, so we are going to use the right-hand side, the rightmost form of rule number 2. And to do that, you're going to have, this will equals to delta 4 over 4 plus delta H over H plus delta W over W. That's the relative uncertainty multiply 4HW, which is the value itself. This together is the absolute uncertainty of delta 4HW. And now you plus delta A. Now we can put in the numbers. This first one is 0. Second one is delta H over H, which is 0.01 over 2.49 plus delta W over W, 0.01 over 2.10 times 4 times 2.49 meters times 2.10 meter. You see, I keep the units except when I calculate the relative uncertainty. 0.06 meters squared is delta A, and you find that to be 0.244 meters squared. Because this is already absolute uncertainty, I can round it off to 0.2 meters squared. And now your final answer will be the paper the decorator needs paper, the wallpaper he needs is 1 decimal place, 1 decimal place. So 17.4 plus minus 0.2 meters squared. Some people like to keep an extra digits. We do allow 2 digits for the uncertainty. So if that's the case, you can also do this. So round this to 0.24 meters squared. That if you do it that way, then your answer will be 17.41 plus minus 0.24 meters squared.